Thank you, Jenny, and welcome everyone to today's webinar, Introduction to Steel Reinforced Polyethylene Pipe for Storm and Sanitary Sewer Applications, which will be presented by Martin Barrette from Armtec. We have a lot of great content to cover, so we'll get started right away. My name is Janine Yetke, Director of Marketing, and my group runs Armtec-Drainage Solutions webinar program, and I'll be your host for today's event. We are now offering our webinar through a new platform. With this change, we're excited to offer new functionality, including the ability to download brochures, other project information, and your CPD certificate right from your home screen. These documents can also be accessed through the menu at the bottom of the screen. We hope that you find these added features useful. At any time during the presentation, you can enter questions through the question log located on the lower left-hand side of the home screen. We look forward to your questions, and we'll take some time at the end of the presentation for a Q&A session. Attending this session will qualify you for a 1-hour technical and formal CPD credit. You can track your progress toward the credit on your home screen, and at the end of the presentation, you can now download your certificate on the spot. Please note the certificate must be downloaded prior to the end of today's session. For those who are attending as a group, please identify someone in the room to gather the required details and send a complete attendance list to drainage_webinars@armtec.com. Please note that the email address is relatively new, so please jot it down. I will start off with a brief introduction to Armtec. We are one of Canada's oldest and largest infrastructure companies, supplying a full range of stormwater management products, soil retention, and steel and HDPE-based bridge and culvert materials, as well as precast building systems. We have extensive coverage across Canada with plans, sales representatives, and regional engineers to assist with project designs and challenging project requirements. At Armtec, we provide solutions for a better world. We strive to be a leading provider of infrastructure solutions that deliver social, environmental, and economic benefits for an ever-changing world. We serve numerous sectors, including municipal, forestry, transportation, commercial, retail, and residential construction. More about how we service these sectors can be viewed on our website or through discussion with one of our experienced sales representatives. With aging sewer infrastructure taking its toll on municipal budgets across the country, it's time to look at alternative products that provide better value for the tax dollar. Our presentation today will focus on the latest advancements in flexible pipe technology with an introduction to Armtec's new BOSS 3000 Steel Reinforced Polyethylene pipe. Content will cover the design, installation, and maintenance of large-diameter flexible SRPE pipe systems. Presenting today is Martin Barrette. Martin is Armtec's Product Manager of Stormwater Pipe. Martin holds a civil engineering degree from Laval University in Quebec City and is a professional engineer registered in the province of Quebec. Martin has over 25 years of experience in the urban infrastructure market. More specifically, out of those 25 years, more than 20 have been spent in the thermoplastic pipe industry for water and wastewater applications. Martin has held various positions in sales, field support, and technical roles, both in the United States and Canada. During his career, he has worked to educate and provide design and field assistance to various stakeholders in the safe and durable use of thermoplastic and composite pipe systems. I will now hand off this pipe to Martin. Welcome, Martin.
Thank you very much, Janine. The first thing I'd like to do is thank our audience for taking an hour out of their busy schedule to join us at this Armtec webinar. We really appreciate it. And one thing we like at Armtec is to know our audience better. So that's why we have poll questions throughout this webinar presentation. And we're going to start with a poll question just so we can understand the audience and we can have a better view of what's important for them. When the slide with the question comes up, we'll give you 30 seconds to answer that question. And what is really nice, a nice feature, is we're going to get the results in real time. So our first question is, we'd like to understand what is the most important factor you look for when selecting a pipe material. Is it durability, the fact that it is a certified product, the cost, the ease of installation, or the familiarity that you may have with the product that you're looking for. So I'll give you a little bit of time to answer, and we're going to then proceed forward. Well, I like to see that the number one answer is durability, and this is something that will certainly be addressed throughout the webinar today. So our agenda is as follows. Why combine steel and HDPE into one pipe product? And then how such a steel reinforced polyethylene pipe has been designed, the next generation of steel reinforced polyethylene pipe, the benefits of using the features and the benefits of using a steel reinforced polyethylene pipe. Then we're going to discuss how this next generation of steel reinforced polyethylene pipe made by Armtec meets and exceeds the requirements of the CSA standards. We're also going to then move on into the basic installation procedures and post-installation testing procedures for steel reinforced polyethylene pipe, and we're going to have a brief summary at the end. So why combine steel and HDPE? Armtec has been in existence now for 110 years, and from day one we were manufacturing steel products, steel-based products. So as you can imagine, we know and we understand steel extremely well. And we've been producing HDPE pipe now since the mid-90s, so it's been almost 30 years. So we have a very good understanding of what the strengths and potential weaknesses of both products are. And this is just that. Why combine steel and HDPE? By combining steel and HDPE, we want to maximize both material strengths and qualities, and we want to minimize as much as possible their potential weaknesses. So for example, if we're looking at steel, we know that steel offers you tremendous strength and resilience. It also has a very linear response to loads when it is used within the design service range for what it is intended to. On the other side of the coin, HDPE is one of the most stable thermoplastic available in the marketplace. So we know it offers unrivaled corrosion resistance. It has superior abrasion resistance, and it's got one of the best hydraulics properties of all pipe material out there. So we want to maximize the strengths of both products and minimize the potential weaknesses. But we also want to make sure that we bring to market a product that answers the need of said market. So right now in the municipal market, and our people, ladies and gentlemen in our audience, I'm sure you struggle with these issues every day in your work. We're dealing with an aging wastewater and stormwater infrastructures. We have a funding gap that has been clearly identified. There's not enough funds for all the needs that our infrastructure systems are faced with. Climate change is also adding in an increased level of pressure on our older infrastructures. I don't know if you're like me, but it seems like every 5 years we hear about a 100-year storm event happening in our locality, in our cities. The infiltration and exfiltration at the joints has been a major issue leading to unexpected system failures. And obviously, you guys are the professionals, so there's a lot of pressure from citizens and elected officials for you to solve the problems. Why don't you solve the problems? So how do you set your priorities to retrofit systems, to prevent failures, to maintain the system, let alone then try to expand and upgrade the system, to answer the citizens' demands and to satisfy the elected officials? Because one thing that needs to be kept in mind at all times, every dime that is spent comes from either rates or from taxpayers' dollars. So how do you maximize your tax dollars? That's another very important issue. We've looked at what the Federation of Canadian Municipalities has done recently, working with their members. And it has been clearly demonstrated that up to 1/3 of Canadian municipal infrastructures are either in fair, poor, or very poor condition. And this is from the Canadian Infrastructures Report Card, published in 2016 by the Federation of Canadian Municipalities. Once your infrastructure reaches a state that is called fair, poor, or very poor, what it means is that immediate intervention is required for your infrastructure to remain in service. So when you combine all this, we feel that we're facing some kind of a perfect storm. We've got aging infrastructures, we have climate change putting an additional intense pressures on our older systems, and we have limited funds. And this table here, again, comes straight out from the Canadian Infrastructure Report Card. The Federation of Canadian Municipalities and their members have established that you need to reinvest at least 1% of the overall value of your infrastructure just to make sure that it remains as is. But unfortunately, our municipalities are faced with more needs than they have money for, and they can only achieve about 30% of that lower reinvestment target on the storm sewer side, and only about 70% of that lower reinvestment target on the wastewater side. So unfortunately, what this means is that what is good today will be fair tomorrow, and what is fair today will be poor or very poor tomorrow. So we're facing this downward spiral, and it's something that we need to put an end to as wastewater and as infrastructure experts. So again, why combine steel and HDPE to create a larger diameter pipe offering while there are already large diameter pipe options available in the marketplace? Well, these large diameter pipe options unfortunately have issues. Most of these options are very heavy material, so they're susceptible to differential soil settlement that may cause joint integrity issues. Their joint design offers very limited insertion, which can lead to potential leakage risks all over your system. Corrosion is a major issue. The fact that these products are very, very heavy will create a safety issue in the trench. And also, it will require for these pipe materials to be made in very short lengths. So you will have an increased amount of joints in your system. And the more joints, the more risk you have of infiltration and exfiltration. And the quality issues might reduce service life, as well as the fact that one approved product material is susceptible to leading to higher prices. So with all this being said, how did Armtec go about creating the next generation of steel reinforced polyethylene pipe? Well, we started by looking at the reinforcing profile of said steel reinforced polyethylene pipe, and we wanted to have a very stable, we wanted to have a reinforcing profile that had a demonstrated capacity to withstand stress and loads. And we've come up with an omega steel shaped rib profile, basically an arch. And even in Roman times, they were building aqueducts based on the arch system, and some of those are still standing. So we feel that this next generation reinforcing rib profile in the shape of an arch is the most stable reinforcement we could put on a steel reinforced polyethylene pipe. This allows us to offer a complete range of large diameter pipe, steel reinforced pipe systems from 1050 millimeters to 2100 millimeters. And what is a game changer, and we will be looking into that later in the presentation, all diameters will offer you a minimum pipe stiffness of 320 kPa. We have done away with the variable pipe stiffness that are allowed in standards. We are offering you the strongest pipe in the marketplace. We also wanted to have a very good joint, and we're going to look at that joint in more details later in the presentation, but our joint will be sanitary sewer capable and tested at 100 kPa of hydrostatic water pressure. The bell itself provides you with the same stable omega-shaped rib profile reinforcement. So the bell gives you 320 kPa of stiffness. So simply by putting together your joint in the field, inserting a 320 kPa stiffness spigot into your bell, you've just created the strongest part of your pipeline at the location where it's most important, at the joint. It's a smooth inside wall. It's made of polyethylene. There is no need to change the hydraulics, softwares, or design methods that you've been using. You can use steel reinforced polyethylene pipe being sure that it offers you the same flow capacity, volume, velocity, everything that you're used to when using smooth thermoplastic pipe. We've selected an orange interior color because we feel this is a tremendous advantage when TVing your sewer lines after installation. A clear orange color will help bring focus to anything you want to look at inside your pipeline compared to other darker colors of existing pipe offerings right now in the marketplace. And finally, it was very important for us that our pipe product not just meet the requirements of the standard, but be certified as meeting and exceeding the requirements of the standard. So in more details, how did we come about and design the next generation steel reinforced polyethylene pipe design? Well, obviously, we'd start with galvanized steel. This is your first layer of protection against corrosion. That galvanized steel is then cleaned and a polymeric bonding agent is applied to both sides of it. It is then shaped into the arch or omega shape profile that we want. It is then coated with HDPE and it will be helically wrapped around your inner conduit of polyethylene. So there will be no steel-on-steel connection. It is a continuous reinforcing rib from one end of the pipe all the way to the other end of the pipe. So we feel also this will help distribute potential localized loading points that may occur when you're installing a pipeline and make your pipe more resilient. So once the steel reinforcing rib has been coated with HDPE on both sides, it is then wrapped around the inner pipe and the steel ends up being completely encapsulated in HDPE. So we're using HDPE for what it does best, provide long-term durability. The HDPE will be facing the effluents. The HDPE will be facing the backfill material on the outside of the pipe. Steel is used for what it does best, provide strength and resilience. So the steel will be supporting the loads to which the pipe is subjected when it is buried underground, and the HDPE will provide the durability. I'd like to show you a larger image of the reinforcing rib profile, and as you can see, the polyethylene is outside, then the whole thing is, there's polyethylene inside the reinforcing rib, and then the whole thing is completely encapsulated by the inner liner. And when the outer reinforcing rib is brought onto the inner liner, HDPE has been heated past its melting point. So what happens here is a fusion process. It's not glued, it's not cemented, it's not welded, it's HDPE fused together past its melting point. So it's a very, very strong bond. Just to give you an idea, this is 2100 millimeter pipe coming out of a pipe making machine. And look at the, if you take a moment and look on the left side of the picture, just to give you an idea of the sheer size of this equipment, you can see people working on the machine here on top and at the bottom of the machine. So this is a very big undertaking making these large diameter pipes. So what are the features and what are the benefits of using steel reinforced polyethylene pipe? Well, I think one of the most important features and most advantageous benefits is the fact that it offers a superior joint. At Armtec, we look closely at all the joining methods that are available in the marketplace, you know, from welding, fusing, threading. We looked at all that. But we came to the conclusion that the most tried and true joining method remains the good old gasketed bell and spigot joining system with which contractors are familiar across our country. But by doing this, we wanted to have the deepest insertion of these large diameter pipe offerings. So we offer more than up to twice the insertion depth compared to more traditional pipe, large diameter pipe material in the marketplace. And we feel this will help withstand potential differential soil settlement or potential pullouts. Also the fact that our joint is sanitary sewer capable. So at our facility, we will test our joint to 100 kPa or 15 psi of hydrostatic water pressure as per the requirements of the CSA standard. So here's a picture of a 2100 millimeter joint for steel reinforced Boss 3000 pipe. So on the left, you have your spigot end, and you will have a gasket installed on the spigot end, and on the right, you have your bell end. So just like any traditional bell and spigot installation, pipe lubricant shall be applied to the inside of the bell, and pipe lubricant shall be applied to the gasket end, and you will simply push one pipe into the other, therefore having assembled and created the strongest part of your pipeline. Now, when building a sewer system, you need to be able to connect to manholes and to different structures. So the steel reinforced polyethylene pipe will offer you great versatility when it comes to that. We can connect to the good old-fashioned traditional method of inserting pipe into a concrete manhole and grouting the opening. We can also connect to manholes using the A-lock flexible gasket that is casted inside the manhole opening, or partnering with a company called Trelleborg, we can also connect to manholes using their core and seal system to connect to manholes. And this will lead us to the next poll question. And the next poll question, we'd like to really understand, as we're bringing the pipe to market, the sizes of the leads that will, we're talking about manholes here, but then if we look at the catch basins on the storm sewer system, we'd like to understand what are the size of the leads, the catch basin leads. So what are the typical sizes for your catch basin's lead connection when installing a storm sewer system? Is it 200 millimeter? Is it 250 millimeters? Or is it 300 millimeters? I think we can move on to the answers. Well, it's a pretty even spread, so we will make sure that whatever is needed will be available. So this is where the next slide comes into play, because even though we're talking about very large size trunk sewer systems, we also do realize that sometimes a service connection might be needed. So we've partnered with a Canadian company that is expert in the development of insertion saddles, and we're bringing to market the Boss 3000 Adaptee that has been specifically designed to adapt to our Boss 3000 pipes corrugation. And right now, the offering is available in 100 and 150 millimeter for service connections, with larger sizes being developed. And what you do is you're using a specifically designed coring hole saw with a guiding tool that will be provided by Armtec to core a hole inside on the wall of your Boss 3000 pipe, then install the Adaptee service connection with the stub end here, and insert your service line into it. And this will lead to another poll question, just so we make sure that we provide our audience with exactly what they need. And what are the typical sizes for your sewer service connection when you design either a storm or sanitary sewer system? Is it 100 millimeter? Is it 150 millimeter? Or is it 200 millimeters? I'll give you a bit of time to answer again. And I think we're going to move on to the answers. And again, we see that, well, the 150 dominates, but we're glad to see that the 100 and the 200 will also be made available to answer the needs of our customers. And when it comes to larger sizes, Armtec has made a substantial investment in robotics, so we can actually manufacture larger diameter fittings. So if you need a lateral that, for example, a reducing T going from 1200 to 600 millimeter, if you need manifolds, because the Boss 3000 pipe can certainly be used as a stormwater retention detention system, everything that will require a larger connection than what we just showed you, we've invested in these robotics equipment that will allow us to manufacture fittings that look great and are in accordance with the requirements of the CSA standards. Now, another feature of benefit of using steel reinforced polyethylene pipe is, like I said, the fact that we are relying on HDPE for durability. And it has been widely demonstrated that HDPE offers the widest range of pH environments into which it can be installed. So knowing this, we know that BOSS 3000 will be immune to the corrosive effects of either hydrogen sulfide gas, which can lead to the buildup of sulfuric acid in your sanitary sewer systems. BOSS 3000, if it's used in a storm sewer system, unless you end up with jet fuel in your storm sewer system, which would be indicative of more major issues, typical contaminants that can be found in storm sewer systems, BOSS 3000 will be able to handle that very well. Steel reinforced polyethylene pipe will also be immune to the de-icing salts. They are a reality in our country. I mean, we need to apply those to our roads to keep them safe. Well, they flow into the stormwater systems or into the culverts. And the fact that steel reinforced polyethylene relies on just that, polyethylene, for the protection against corrosion, means that they can be used very safely. And finally, if you live on the either coast of our great country and you're using our product into marine or tidal conditions, well, it will not be an issue for steel reinforced polyethylene pipe. The other thing that polyethylene is widely recognized for its resistance to abrasion. Abrasion has been extensively researched. Abrasion of pipe material has been researched by the University of Saskatchewan, the University of California. Research has been conducted in Germany as well, always based on the same principle. They're using different pipe samples made from different pipe material. They're filled with standardized abrasive slurry and capped on both ends. These samples are then put on a tilting table, and they start creating these cycles by tilting the tables, and for several hundred thousands of cycles. And at regular intervals, they will stop the process, remove a piece of the sample, and measure the amount of material that has been eroded away. And all research has clearly demonstrated that HDPE offers the highest resistance to abrasion, with other thermoplastics being close in performance, and clay pipe performing surprisingly well. But the only issue with clay pipe is it's not manufactured anymore in Canada. So if you look at being able to resist the effluent abrasion, if you're using the steel reinforced polyethylene pipe in a storm sewer application, typical abrasive material present in storm sewers and or sanitary sewers will not be an issue. There's also a great safety involved when backfilling the material. Simply dropping the backfill from the excavator on top of the pipe, the HDPE is more than capable of handling that and will protect the steel throughout the installation. And it's also ideal for a highly abrasive culvert application environment. So should you choose to use steel reinforced polyethylene pipe for a culvert application, you can rely on the long-term durability of polyethylene, high-density polyethylene. Another great feature of steel reinforced polyethylene pipe is its lightweight. I mean, it is the lightest of all large diameter pipe material. Our weight range from 42 kilogram per meter at the smallest size all the way up to 136 kilogram per meters for our largest size. If you compare that to the more traditional rigid pipe material offered in the marketplace, I mean, we're talking about almost 3,000% difference at the largest size. So this means improved crew safety in the trench. You need lifting equipment still on your job site, but you might be able to get by with a smaller size piece of equipment, which means reduced costs for installation and a higher rate of installation, because our pipe is lighter and offers longer lay lengths. So even if at the end of the day you're installing the exact same number of pipe sticks in your trench, you will have installed 3 times more pipe, because the steel reinforced polyethylene, being 6 meters in length, means that you have almost three times more pipe installed every time you lower a stick of pipe in the trench. Steel reinforced polyethylene pipe is classified as a flexible pipe under the CSA standards, and as such, it can be installed relying on the CSA B182.11 standard practice for the installation of thermoplastic, drain, storm, and sewer pipe and fittings. I'm sure all of you in our audience are familiar with these typical trench designs that are excerpts from the CSA standard I just mentioned. And what is part of the game changer I was mentioning earlier in the presentation is the next generation of steel reinforced polyethylene pipe, BOSS 3000, offers you a minimal pipe stiffness of 320 kPa for all sizes. So it means that if in the past you've been using flexible pipe 900 millimeter and smaller and have enjoyed great success doing this, you don't need to worry as you migrate to a larger diameter pipe, because this larger diameter pipe offers you less stiffness. It used to be the case in the past, but now our pipe offers you the same stiffness. So the installation methods that you were using will translate and will be replicable in the larger pipe sizes. Just to give you an idea, if you look at the BOSS 3000 next generation of steel reinforced polyethylene pipe, even when you compare to what is allowed in the CSA standard B182.15, that is the CSA standard for steel reinforced polyethylene pipe, that standard allows variable pipe stiffness, so a decreasing stiffness with increasing size. Well, Armtec wanted to outperform the standard, and we are offering you a minimal stiffness of 320. In the larger sizes, it means that we bring to the table more than 3 times the stiffness of compared to the first generation of steel reinforced polyethylene pipe. If you compare that to the requirements of CSA B182.8, which is the standard that applies to corrugated HDPE, as soon as you exceed 900 millimeters, again, the standard allows for variable pipe stiffness. So at the largest size, we bring to the table more than 3 times the pipe stiffness. And even compared to the ASTM F894 type of pipe material, which are categorized using a ring stiffness constant, well, if you enter the ring stiffness constant into the ASTM equation that converts it into pipe stiffness, even under that standard, variable pipe stiffness is allowed. And on the largest size, we bring to the table more than 2 times the stiffness of the competing material. And one of the features that we're most proud of is that the BOSS 3000, the next generation of steel reinforced polyethylene pipe, is manufactured right here in Canada. It is a first for such a large diameter steel reinforced pipe material to be made in Canada. So we're proud to offer that to our Canadian customers. This being said, making a good product is one thing. Making sure it meets and exceeds the CSA standards requirements, that's what's important. And we wanted to be certified as doing so. And it was quite an undertaking because, believe it or not, there wasn't a single facility in Canada that could test such large diameter flexible pipe in one location. So we had to actually build a testing facility at our manufacturing facility. So part of the reason is CSA standards requirements have this built-in requirement that pipe samples be preconditioned at 0 degrees Celsius before they undergo testing. So this is a sample of our next generation steel reinforced polyethylene pipe in a freezer that was built at our manufacturing facility before the pipe will undergo the impact test. This is the impact testing equipment. Inside of this tube, there is a standardized hammer as per CSA and ASTM requirements that will be raised to a standardized height as per CSA and ASTM requirements and dropped on the pipe to ensure that the manufacturing process was a good manufacturing process. Then you want to be sure that your joint meets the requirements of the standard. So this is a joint integrity tester that we had to build at our facility. I know it's a little bit difficult to see because it is black pipe on black pipe, but this is the bell right here, and the spigot has been inserted. We cap both ends, and then the hydrostatic water pressure is raised to 100 kPa for a duration of 10 minutes. Once that is done, using these metal bars here, we deflect the joint for 5% and also do hydrostatic test at 100 kPa. And once the pipe is emptied of the water in it, a vacuum test is also conducted. And it's also very important to be able to validate the stiffness of your pipe. So we needed to acquire a machine that could actually do a stiffness test on a pipe 2100 millimeter in size. So this is a picture of the machine. What is done is you deflect the pipe to 5% and you measure the stress, and in our case, we want it to be at 320 kPa. And part of the testing requirements is to keep increasing the deflection to validate the quality of the extrusion in the manufacturing process. So, like I said earlier, decreasing stiffness with increasing size was just not good enough for Armtec. We wanted to surpass the requirements of the standards, and this is why this is the next generation of steel reinforced polyethylene pipe. And through all sizes, 320 kPa, which is more than 3 times what the competitors can bring to the table when it comes to the larger sizes of steel reinforced polyethylene pipe. And all this has led to the Holy Grail. Armtec's Boss 3000 steel reinforced polyethylene pipe is currently the only steel reinforced polyethylene pipe in the Canadian market that is certified as meeting and exceeding the requirements of the CSA standards. And this certificate of compliance can be found on the CSA Group standard. We are listed by CSA, a third-party examiner, as meeting and exceeding the requirements of CSA B182.15. And I want you to know that this is the sanitary sewer standard, and this is the most stringent of the 2 steel reinforced polyethylene pipe standards. So should you decide to use our product as a storm sewer or a culvert, you would still receive a pipe that is sanitary sewer capable. One important thing to keep in mind. So knowing that the product is a good product, third-party certified to CSA standard requirements, now it's about time to talk about how the basic installation procedures would go about. And like I said, this product can be installed as per the requirements of the CSA B182.11 standard installation. And we also publish at Armtec a very detailed installation guide that can be downloaded from our website anytime you want to have a look at it. And I mean, maybe I'm going to state some of the obvious, but after more than 25 years in the field, I've come to realize that sometimes the obvious needs to be restated. So you want to be sure that as the pipe reaches your job site, you're actually receiving what you have ordered. You want to be sure that you're not rolling pipes off the truck, please. You want to be making sure that you hoist the pipe individually using fabric slings. The unloading zone must be relatively level, free of debris that could damage the pipe. And the pipe should be laid flat on a flat grade and with blocking to prevent those from rolling or eventually rolling into the trench and hurting a worker down there. The pipes will be delivered with a protective cover on the spigot and gaskets. These coverings should remain in place until the pipe is actually ready to be installed in the trench. Obviously, we recommend that the consulting engineers or the city specifications be followed, but if you are looking, for example, for detailed information about the minimum trench width, this is information that can be found into our installation guide. If you're looking, for example, for height of covers, it can be found in our installation guides. We will provide you information on how to proceed. So the pipe should be laid as close as practical to the trench, obviously. The bell ends, they should point towards the direction the work will progress, because you will be inserting spigot into bell. That's the best way of preventing granular material to enter the joint. So if your bell is clean and you're inserting the spigot, makes it that much easier. Do not roll the pipe to the bottom of the trench for obvious safety reasons, and you want to make sure that you're protecting your people in the trench, so pipes should be lifted with the appropriate equipment. Make sure that the bell and the spigot are clean. Remove the protective covering from the spigot, and the pipe lubricant should be applied to the inside of the bell and some on the spigot end. And then once your both ends of the pipes are properly prepared, you align both pipes at the bottom of the trench and you insert the spigot into the bell end using either a nylon strap around the pipe that is about to be inserted or a push piece that we can supply in the bell at the other end of the pipe that you're about to insert. Using a push piece will also help prevent potential damage to the bell of this new pipe that you're pushing in. Make sure that a worker is always present at the bottom of the trench to guide the excavator operator. The worker will know when the pipe has been completely inserted and will be able to signal the operator and make sure that no excessive force is applied to the pipe. And finally, backfill with the approved granular material as per the requirements of CSA B182.11 or the local requirements in the region you live in. Again, this is another example of what you can find in our detailed installation guides. Those are the minimum height of covers. These are calculated as per the LRFD design method of AASHTO. But just so, ladies and gentlemen, you know, Armtec has partnered with the Geoengineering Center at Queen's University in Kingston, Ontario, to have life-size testing of the next generation of SRPE pipe. And once all the results are published by the Geoengineering Center, we will be able to publish updated height of cover tables based on real-life testing measurement done by one of the most respected geoengineering center in the world. Once a pipe is installed, it needs to be tested after installation. And we also provide a very detailed post-installation guideline for steel reinforced polyethylene pipe. So basically, the post-installation testing can be done to make sure that the joint integrity is good and that deflection is within the allowable requirements of your jurisdiction. So just like any other sewer pipe, Boss 3000 can be CCTV'd, and because of the orange color, we do feel that it's going to be an easier process to identify any potential issues inside your pipeline. Then you can test for water infiltration or exfiltration as per ASTM F2487. Obviously, the exfiltration testing is acceptable in dry areas only. If the water table is above your pipe, then an infiltration test is required. Again, if you look at the requirements of the standard, CSA B182.11, the allowable leakage rates are 4.6 liter per millimeter of ID per kilometers per day for sanitary sewers, and 18.4 liters per millimeter of ID per kilometer per day for storm sewers. And finally, this being classified as a flexible pipe, there might be limited deflection, and this can be measured either by using a mandrel or by using these new laser profiling systems that have gained more presence in the field. So, in summary, we feel that steel reinforced polyethylene pipes, by combining the superior strength of steel and the very long-term durability of HDPE, they form a superior pipe product for use in your sanitary and storm sewer systems. The steel, like previously mentioned, is completely encapsulated in HDPE to protect it against corrosion and abrasion. So we rely on the HDPE to provide you the long-term durability in a design service life of at least 75 years, and steel is relied upon for what it does best, its strength. The SRP, the next generation of steel reinforced polyethylene pipe made by Armtec, are certified as meeting and exceeding the requirements of the CSA standard B182.15. The steel reinforced polyethylene pipe made by Armtec also offer a minimal pipe stiffness of 320 kPa, which is above and beyond the requirements of the standard, which allows variable pipe stiffness. Like I mentioned, variable pipe stiffness wasn't good enough for Armtec. Steel reinforced polyethylene pipe, they can be installed just like any other traditional flexible pipe material as per the requirements of CSA B182.11. And finally, the next generation of steel reinforced polyethylene pipes from Armtec, they're all made in Canada. All this being said, we're nearing 10 to 1 Eastern. I just want to say thank you very much for the attention and for taking the time out of your busy schedule to join us for this webinar to introduce the next generation of steel reinforced polyethylene pipe. And I will give the floor to our host, Janine.
Thank you, Martin. Thank you for your presentation. And for everyone on the line, thank you for joining today's webinar. We hope that you found this presentation informative. Feel free to contact us at any time if you have further questions or would like assistance for an upcoming project. Our question and answer period is coming, so please feel free to submit any more questions while we're going over some housekeeping items, and we will get to them very shortly. On May 1st, we will be presenting the same webinar in French. So if you are interested, feel free to go to the armtec.com website and register for the French version of this webinar, or stay tuned with us for some new content coming up in the fall, because this concludes our spring English webinar series. To stay informed, please stay connected with us. You can follow us on social media on Facebook, LinkedIn, and others, and you can get the latest on Armtec by following us on our website, armtec.com. We would appreciate it if you could take a minute and answer a quick survey about this webinar that's available on the console in the upper right-hand corner. You can also use this to request a sales call or lunch and learn. The survey will also be available after the webinar is over, but you'll have to allow a pop-up on your browser. We value your feedback and would like to know what you think of this event. Due to strict Canadian anti-spam legislation, we are required to have your consent to receive future emails from us, so please provide us your email to ensure that you're on our mailing list. Finally, don't forget to download your CPD certificate from the menu at the bottom of your webinar console. And if you're attending in a group, please send the names and emails to drainage_webinars@armtec.com and we will send you your certificate. Please note that due to spam filter settings, emails might not get through to your inbox, so please keep an eye on your spam and junk mail folder. Now we will move into the question and answer portion of the presentation. We have had quite a few good questions come in, so if we do not get to all of them today, we will be sure to respond to you by email, so please feel free to continue answering your questions because you will get a response from us. Okay, so Martin, we've received a few questions about the design service life of the product, assuming that all maintenance guidelines are followed. Can you comment on the design service life?
Yes, the HDPE, like I said, has been is widely recognized as the most stable of all thermoplastic, and extensive research in the United States and Canada have established the service life as at least 75 years. I know it's recognized this way by the NTO, and several other utilities are relying on plastic pipe to serve them for a very, very long time. And it's always, if I may just digress a little bit, it's always a little bit funny to me when people are worried about plastic ending in a landfill and saying it's going to be there forever. And well, then a plastic pipe lasting 75 years on the ground should not be a surprise to anybody.
We've also received a number of questions about the cost. How does this cost look like compared to conventional CSP, RCP, and HDPE pipes?
We have, when doing our market research and making sure that we're producing a next generation of pipe that was answering technical needs and, answering issues that municipalities and consulting engineers were dealing with, we also wanted to make sure that this product would answer it at a reasonable cost. And we know for a fact, having tendered a few projects since the beginning of the year 2018, that we are very competitive. We have won our fair share of tenders, and the product will, if you allow the product in your specification, you can rest assured that contractors will closely look at it and that we will be very competitive and be able to serve you very well.
There's a question, what is the acceptable angular deflection of the joints?
Right now, and this has been discussed with our chief engineer, we're talking about 1 degree maximum. We would much rather offer you, if there's a need for deflection or, change of direction in the field, that's why we invested so heavily in robotics and robotic equipment. We want you to do it safely with the use of fittings. And we can certainly make bends, long radius bends, or 11-degree bends, 90-degree. We can manufacture a fitting that will allow you to change direction in the field.
Okay. The next question is, how do you ensure the bonding between the HDPE and steel are reliable in the hybrid product?
Okay,
and there was
it's a very good
to review the bonding between the polyethylene to steel and the polyethylene to polyethylene.
Okay. It's a very good question, and as part of the manufacturing standard requirements, it is required that the strength of the bond between steel and HDPE must be higher than the tensile strength of the HDPE proper. So it means that if you push the material to ultimate failure, the HDPE should tear up before it comes away from the steel. And I mentioned during the presentation that we have partnered with the Geoengineering Center of Queen's University in Kingston. And part of the testing was to actually make sure that the profile we had selected was fully engaged when subjected to soil loads. And in order to do this, they took we provided them with samples cut from our pipe wall, and these were put between 2 compressive plates, and they were brought all the way to failure, the buckling of the steel. And while this was done to make sure that the profile was indeed strong enough to provide the 320 kPa stiffness and was fully engaged when subjected to soil load, the side benefit was the ability to confirm that none of the samples showed any failures or tearing or peeling away of the HDPE from the steel. And once Queen's University has issued their final research report, we're more than happy to provide detailed information about that.
Thank you. There's a question, are there any concerns with colder weather insulation? Example, would it be brittle in cold weather insulation?
Well, HDPE is the most resilient of all thermoplastic, even in cold weather. And if you look at our profile, the fact that we're using a rib, an omega-shaped rib profile, means that the steel is quite present all along the length of the pipe. So steel will be the dominant factor when it comes to expansion and contraction, which will limit greatly the issues related to temperature change when using the product, because steel will be the dominant factor.
There's a question, when will the product be available for sale in Western Canada?
Okay. The product is, we are manufacturing pipe right now. We have answered tendered in the West, and we have one tendered in the western part of Canada. So I'd say the product is available right now. Obviously, reach out to your local Armtec resource in your region of the country, and depending on your sizes, needs, and the total amount of pipe you may require, we'll be able to give you an estimated delivery date.
There's a question here. Are there markings on the exterior of the pipe to assist ensuring the pipe joint is fully honed?
Yes. An insertion mark.
Yeah.
Yeah. Well, the best way of making sure is if you want to be absolutely sure, you can take a tape measure, measure the depth of your bell, or we provided you with the information, and make a mark. But as we ship pipe, yeah, an insertion mark will be part of product, the finished product.
Okay. How much does UV exposure affect the service life?
The HDPE that we use is the exact same HDPE that we use in our line, our Boss 2000 lines of corrugated HDPE. So it can the carbon black content is the same. So the durability of Boss 2000 is transferable to the Boss 3000.
Here's a question here. What about the installation on the steep slope of 5 to 7%?
Well, there are guidelines when installing any pipe on a steep slope. You can either use a concrete anchor or, different anchor methods depending on how steep is your slope. So this would be part of a more detailed installation process that we would certainly be more than happy to discuss with any jurisdiction, cities, or consulting engineers faced with such a project. Again, we have Armtec resources across Canada. Feel free to reach out to them or to me, and I'll put you in touch with your local resource to discuss these specific needs.
Okay, we've got another question. Is this pipe suitable as a highway culvert?
Yes, it is. Very much so.
Here we go. What is the maximum pipe diameter limited to? Why is the maximum pipe diameter limited to 2100 millimeter only? Any chance future pipe will be larger diameter?
At the present time, and in accordance with the market research we had done before launching this venture, it was recognized that going all the way up to 2100 was answering maybe 95% of the market needs, but as we gain more experience and we get better, will there be larger sizes? This remains to be seen. But at the present time, we're confident that we can help the market in about 90 to 95% of the cases out there.
Okay, Martin, I think we'll take this question as our last, but I'll encourage everybody to keep entering your questions because there are still quite a few coming in, and we will be certain to get back to you. This last question is, the internal surface of the pipe is obviously smoother than a CSP pipe section, but not as smooth as smooth-walled pipe. How does the internal smoothness affect water flow? For example, how much sedimentation can be anticipated within these pipe sections?
Well, I mean, if you look at the inside of a Boss 2000 and the inside of the Boss 3000, they're very similar. So, and we went the conservative route by using the exact same Manning coefficient. So again, there are minimal slope requirements required when installing sewer systems to make sure that these sewer lines are self-cleaning. And I would recommend abiding by those regulations that are edicted either in the CSA 182.11 or your local jurisdiction requirement for minimal slopes installation.
Okay, well, I think that will be the conclusion of today's webinar. And I want to take the time to thank Martin and thank everybody on the line for joining in today. We appreciate your participation, and we look forward to hearing from you. Thank you, everyone.
Thank you.